Okay, my wonderful, outstanding, curious friends, you are about to get psyched out. Well, what is this? This is an asteroid, and its name is Psyche or Psyche, I don't care how you pronounce it, but it is a metal asteroid. It's metal. And we know that metal things come into our atmosphere regularly. They're called iron meteorites. Well, that's basically what this is, only it's got a ton of different metals, all kinds of different metals. Now, why am I showing you this? You see this hole here and this hole here and this little nose looking thing here? Some people say they thought it was a face. Well, let me tell you something. I know exactly what it is. And it's not a face. It's exactly what this is here. You see this dark side with the here, there's a hole in the center, just like there's a hole in the center of Psyche, in each one of those pockets. There's the little nose here. Here's the other pocket. Now, let's back out and see them both at the same time. All right, now, what are we looking at? We're looking at two different objects. This little nose-looking thing is right here, and I'm going to show you, this is anatomical. And it is a heart, and this is also a heart. And here's the bottom part of the heart, you know, where the ventricle sac is. And this died in the flood, has the flat side, just like that. That's the heart right there. And here's the other part of the heart. It's sort of stacked up on itself. And then the two spots here, I don't care how you hold it, this way or that way. This little nose thing is the separation between the two tubes that run into your heart, from the vein side, which is black, and the artery side, which is the red blood. And the red blood grows this green moss on there, which is growing on here. I'm going to show you this in a microscope, but before I do, let's see the anatomical. Don't forget, you see that there's a whole little bump there and a little bump here, and we got these two big entrances. Let's see if we can find that anatomically similar. Okay, let's take a look at the anatomical. We have the ventricle walls here, left and right ventricle, which is in here. Now, hanging off of that, we have this big mitral valve here, and in between the two, we have this, which is the aortic valve, and that's supposed to only let blood go one way or the other. And this, hanging off the other side, is the tricuspid valve. So these are valves going in and out of the heart, and this little one here is this pinch. You see the little bump here and the bump here? You see the bump here and the bump here? You see that little spot right there in the center? That's that little spot. And here's this big opening here, and here's this big opening here, and here's the bottom of the heart, the big bottom of the heart. And this thing weighs a lot. Now, it died in a flood like this. That's because this flat spot, you can see, everything I have almost, just about, is completely flat on one side. And it said in the ancient text there was a very bad flood that was hot water and boiled all the creatures, because we almost got hit by a giant comet. I can explain all that stuff later. But during this event, it boiled, literally boiled, the oceans and the waters everywhere. And all of the creatures, basically, not all of them, but the ones that were in the low-lying areas, the ones that couldn't hide in caves way up on the mountains, they drowned and were boiled to death. And what happened was the boiling waters caused the flesh to degrade and come out and just turn into mud. That's what the clay and mud is everywhere. And some places are red as hell, like, there's a lot of places, very, very red, muddy clays. And Australia is just a slaughterhouse. It's just a saturated scab. It's unbelievable the amount of blood there, and that's why they find opals. Opals are a product of all of these transition metals. which are in the blood. We're going to go through the chemistry in a minute. And all of these transition metals, which are the metals in Psyche, that asteroid, are also in blood. That's what's in blood, is its transition metals, and that's what's in that heart, because hearts are made of, basically are filled with blood. I mean, obviously, if it's working. Okay, so we know that Psyche out there has all these different metals in it. And these are the different color states that these metals take on when they're in the body, because they're used to transport molecules here and there with these oxidation states. You see this here, it says transition metals form colored compounds and complexes. They get very complicated. These colors can vary depending upon the charge on the metal ion. So vanadium can have a 2, 3, 4, 5 charge on there. So it can bond with all kind of different things to carry it around your body. Vanadium's got to be really important, so is chromium. Now, this is the charge on these metal ions can change, and then the number and type of groups of atoms, the ligands which attach, change on these metal ions. So in water, in aqueous solutions, watery solutions, the ions form complexes with the colors shown to the right. So in bloody, watery solutions, aqueous, you're going to see all these colors, and that's in your blood. Let's see if we can find that in a heart. Okay, this is a human heart, and this is obviously a complete heart, and it has all these attachments up here, tubes going everywhere. They always seem to break right across here, and that is what is broken here. All right, this is what we have here, is we have this bucket here heading down into this ventricle, and that's right here. Here's the little pinch. That's this little pinch right there, you see it? It's the same little pinch. And here's this one is over here. So this is the bucket here that's letting the blood come in. And this is the bucket here that's letting the blood go back out. And this is the pinch right here in between them. So that's a real heart. Now, let's look at one that turned into an opal. Okay, this is that heart again, the one I have here in my shop, and this is literally the blood that's in the heart, in the ventricle, and this is the ventricle wall, and this is the red bloody muscle that forces the blood to squirt in and out. And here it is right here. I don't know if you can see it. I have to keep it dark in order for the things to show up well. But what we were looking down at right there is that scene right there. All right, right between the ball of blood, basically, and the wall of the heart. Okay, so here's my claim. My claim is that that little pinchy spot right there is this little pinchy spot right here. That's the valve, the aortic valve. Each side of these are the ventricles, right and left ventricle, and they are down inside the heart. This scoop right here is exactly this scoop right here. And this is artery blood, and that's why this is red and has all the moss growing in it. This is the vein blood, and this is that scoop right here. All right, all of this stuff above is gone. All the tubes just broke right off. Now, and you can see this is blue means that's vein, and that's vein. And this red means it's red. Now, and what hangs off of that is the bulbous part of the heart, which basically is this. And don't forget, it was just laying flat on from the flood. There's the flat side, and I can see actually the fibers and everything that make up the fascia on that side. All right, this is an iron meteorite. Came through space. That's red blood, and that's the vein blood. Everything cooked off. I think this could have been a liver or a heart or a lung, I don't know, but they all have the same thing. You have to have artery and you have to have veins. Now, why all of these different crystalline different structures here. Those are all the different trace metals that have collected against themselves as it's smelted off. So some of this is iron and cobalt and whatever it is. Let me show you what the trace metals are in your body, and each one of them will have a different crystalline pattern. You see this? Trace metals include iron, lithium, zinc, copper, chromium, nickel, cobalt, vanadium, and others, and I mean many others. All right, trace metals. And this is all in, right, trace metals and metal subsequent subsets of trace metals. Normally present in small but measurable amounts in animal and plant cells. And there's a zillion of them. They're a necessary part of nutrition and physiology. They are the things that carry things around in your body using those oxidation states. Ingestion or exposure to excessive quantities can be toxic. Well, yes, I'm sure it can be. But if you don't have enough, it's going to be toxic. In the other way, you're not going to have the things moved around and the trash taken out that you need to have taken out. So, and that's what Psyche is made of, and that's what my meteorite here is made. I mean, my heart here is made of. Okay, I just showed you how important blood metals are to transporting things through your body. Now, they did a study on levels of all these different things in your body, and I can't get to the full article, but this is pretty illustrative of what you're going to see here. They're saying there's big ranges, actually. They found, and they did 109 samples, and here's what they found. Let's just take magnesium. Magnesium ranged from 12.5 to 36, with probably, I believe this means the mean is 20.4, and that's what you want to be at, apparently. Look at chromium, which appears to be a very important one. It has a lot of oxidation states, 0.009 to 0.055, and optimal apparently is 0.027. And then, but there's huge swings. I would pay attention to these more than other things, because these are the things that bring in and take away. All right, and anyway, but this is Oxford University Press, and one thing I want to mention is that these metals in these quantities and so forth, I believe they're regulated by bacteria that live within your body. You have literally thousands and thousands of different bacteria. They make enzymes. Enzymes do chemistry, and now there's a new chemistry, they call it click chemistry. Well, it's because it's just magnetic particles. Once you click, you can click billions of particles instantaneously. They all change their state, and that's what an enzyme does. It's an instantaneous molecular vast change of particles, literally millions or a million or possibly in a second or two. You can change them all. And the actual clicker, the one that had the magnetic signature that snapped them to do that click chemistry, doesn't even go away. It's still got another, it go into another million and another million and another million until it has nobody to click with, and then it just ends up getting dissolved. Basically, that's the way proteins work in your body. And these proteins are created by enzymes, and enzymes are created only by bacteria. And the chemistry they do is so enormous, so quick, it's just beyond belief. All right, this is just too cool. These are the bundles of muscle that wrap around the heart to squeeze that when it was fluid and push it back and forth through the body. But these are the heart muscle. Okay, I want to credit Arizona State University for this fabulous presentation showing these heart valves. And that's what they are. You see these little stripes here? These are the same heart valves I showed you in the Anatomical. This is not metal right here. This is, you see the little white fibers and everything in there? This is connective tissue. So is this one. So is this one. So are the ones coming out of here. These are never going to turn to metal. Where the blood was, yes. And let's look at that. Alright, this is about as close as I can get to Psyche. You see this? This is the layer up above. Below is the layer of blood, which Psyche has the same stuff. And down below here, I gotta see down here, this is the layer of blood, and that's the layer of fascia and tissue that coats it. Well, here is Psyche. It's exactly the same, virtually identical. Okay, my friends, Kentucky meat shower. Showered all over this person's property, chunks of meat. This is 1876. Okay, I know it sounds crazy, but these gigantic things are in space, but they are. Comet 67P. I followed this from when it started right to the very end. I know every little detail that anybody knows about this. And they landed a lander on there. It was called a Philae lander. This was the European Space Agency. And they took samples of the actual particles and Fe iron oxides, which are that's what's in your blood. These iron oxides, sodium, silicon, carbon, hydrogen, hydrocarbons. They said yes, it's 100% organic, and they had no way to account for it, so they just dropped it. So now I'm going to show you why I can make the statements I'm making that was a heart and not feel like an idiot, because there's all kinds of other stuff out there that is also biology, as you will see. Okay, this is what NASA has to say about Psyche.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich. It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do. And it would be the first metal object that humankind has ever visited.
We've been approved to go in August of 2022. It'll take a number of years to get there.
Flies past Mars, gives us a gravity assist, uses our propulsion system to then slowly creep up. So at the end of 2025, getting there in early 2026.
We'll go into 4 concentrically smaller orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma-ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic to when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
I agree. And this is a government project. We all pay taxes. I'd like to see it done correctly. And Arizona State University appears to be the one that's doing this. And I've been trying to get through to them. I haven't been successful. So what I have shown, I should think someone would take some interest in. Okay, let's wrap it up. We've seen Psyche is supposedly saturated with metals, and I agree, it's a heart. This is the red blood from a metal iron meteorite. And they smelt off coming through space. And the smelting means to get rid of all the cheap stuff. All the weak molecules get burnt off as slag. And what you have left is all these different crystals of different types of metals. And they crystallize as it cools down. See that? That's the Willamette space meteorite. Came through space and it cooked and turned into iron. And there's all these little passageways, the same thing there is in lungs, because this was a lung. And that's all the red blood that was in this lung is still saturated. But most of it's out. Now, if this had come through space, loaded with blood, it would have done this. Which it did. That's a Willamette meteorite. Now, don't anybody get upset with me from what I'm showing here, because what I'm showing you is I am a material scientist. This is material. These little comas coming out here are coming out because the blood is being boiled that's inside of here. This is comet 67P. That is the artery. These are the little tiny blood vessels. This is a tendon enthesis, and this is where the tendons come up to meet the muscle, which is gone. Get a doctor, somebody that knows anatomy. This is a muscle bundle, and it's coming up here to attach to something, and it's broken off. These are tendon fibers that come up to attach to muscle. The muscle is a weak spot, that breaks off. This is the enthesis. These don't blow off any blood gases because all they are is anchors. They're little pockets to anchor into flesh or bone. Just for scale, this is 67P. That's that anchor, which it could be even a heel, I don't know. But then the tendon comes up, and then you come up to whatever attached at the top here. Now, where this stuff came from, I don't know. There was a whole bunch of stories about wars in heaven. I don't know if that's possible. All I know is these body parts are out there. So is the other one, the fingertip, the finger. Okay, all these institutions, they must have some biologists around here, some anatomists that can look at this and say, yeah, that is the grip skin, the friction skin that coats a fingertip. This is an apical tuft with all the little tendon fibers coming down. This white strip here comes down and attaches down here with all these little balls into an anchor spot right at the joint in your finger. And the same thing here. And this runs down to the knuckle. That's the vein side, which turns dark. That's the artery side, which does not. This is a finger. And the attachments are here. It's quite obvious. I've shown it to anatomists. They agree that if it's not a finger, they've never seen a finger. Basically, I was told it's the fingeriest finger I have ever seen. You see right down here, let me turn this light on. These are the two tendons that go right over the top of your fingers. And this is the knuckle right here. It's right there. And this is all the way up to the tip of your finger. And that is the skin that coats your fingers and your toes and your feet and your palms of your hands. And I have a giant here that has, well, I'll show you. All right, this is the best shot to show you. You see this silver stuff here? This is a left hand. If you put your hand back and laid it flat back, you're going to have this right here, which is a tendon. It's your left hand. The thumb is going to go off this way. You have that little cleave between the pad that runs down here and the other pad. And this silver skin is the friction skin, the grip skin. It's the tough, cornified skin that covers your flesh, so that you can do work with your body, with your fingers and your toes and your hands. And that is what peels off. And that's what's peeling off of a Mara. The one I just showed you is DNA tested and it's human. This was also DNA tested and it is human. It's almost 3 feet long from the back to the very tip. This is a fingernail. Just take your time and look at it. This is the little pad that's between bones so they don't scrub in each other and ruin your joints. All right? This is the vein and artery. This I broke off with a sledgehammer, bang. I thought I was going to have to really whack it, and I just hit it and it would pop right off. And it's the skin, it's that grip skin. And I'll show you that. Now don't forget, almost 3 feet long. The report came back, excellent quality DNA. I extracted it myself after I broke this off so I could get down into the blood. You can't get it off the surface of this particular type. Most of them you don't want to get it off the surface. You have to drill down into it, which is what I always do. Now, this is the grip skin that I was just talking about right here, that I popped off. And when it popped off just like this. Just like that silvery skin on the hand. And here's the fingerprints are still here. That's the fingerprints, as thick as my thumb. One print, one ridge. And it's this cornified skin. So now I get down in here and get the really good blood, and that's what I sent off and had it tested. So I'm really talking from some very, very solid evidence here. I would expect some educational institution, especially Arizona State University, to be interested in what I just presented. Or somebody, I don't care who it is, somebody has to bring this forward, and we have to start discussing what's really out in space and what is really on the Earth. Because the things on the Earth are not understood either. Geology is totally wrong. As you can see, the rocks I just showed you are not rocks. They were body parts.